2.1, factoring whole numbers. Alright, let's look at section 2.1, factoring whole numbers. Now let's look at what this means very quickly. We have factoring whole numbers. Well, what we know for sure is that whole numbers are, back from chapter 1, 0, 1, 2, etc. What does the word factoring mean? Well, let's look at a product. A product, another word for multiplication. Product is made up of two factors multiplied together, at least two factors. So if we have, for example, the product 6, then the factors could be 2 and 3, 6 and 1. These are two numbers when multiplied together make 6. So these are the factors, 2 and 3, 6 and 1. So when we talk about factoring, we're going to take a product, some number, and we're going to break it down into the numbers that are its factors. So that's what factoring is, and then we're going to do that for whole numbers. So that's section 2.1. Okay, the first thing we need to do is we need to talk about even numbers. Specifically even whole numbers, since we're going to be working with whole numbers here. Even numbers, the definition is a number that is divisible by 2. An even number is a number that's divisible by 2. So, what numbers are divisible by 2? And most of my students tell me 2, 4, 6, 8, and so on. Now, one that they usually leave off that I like to make sure to include is 0. 0 is divisible by 2 because 0 divided by 2 is just 0. Just like 4 divided by 2 is 2, 6 divided by 2 is 3. So 0 is considered an even number. So I want you to keep that in mind. I always like to tell students 1's not the loneliest number. Usually 0 is. Okay, now let's take that and let's look at some numbers, just some practice numbers here. For example, let's look at the number 10. What are some factors of 10? And I have students tell me 1 and 10. They're right. 2 and 5. Good. These are all factors of 10. What about 22? 1, 22. 2, 11. Okay. Now let's jump up to 34. Now this is where it gets kind of interesting. I'll ask students, I'll say, what about this one? They'll say, oh, well, we know 1 and 34. And then they'll start talking about it. They'll look up at the ceiling. They'll say, I'm not sure. Maybe I think 2 does. Does 4? So you get all these questions. 2, 4, etc. So what we're going to do is in this class, we want to take things that most people can do for smaller numbers like this, and we want to be able to come up with a way to apply them to all numbers, any number beyond that. We want to set the ceiling a little bit higher. So when we work through this, I'm going to teach you a method of breaking numbers down where you don't have to look at the ceiling or put a question mark. We're going to try to get that taken care of. Okay? All right. So the first thing I need to do is I need to give you some divisibility rules. So I need to give you some divisibility rules. Okay, and the first one we're going to do, and just in case I'll reference this is on page 85 if you need to look this up in the textbook. On page 85 there's a divisibility rule for 2. So this is divisibility by 2. So divisibility by 2 says a whole number is divisible by 2 if and only if the ones digit 0, 2, 4, 6, or 8, or basically an even number. Okay, so now look, a whole number, we know what a whole number is, divisible by 2 if and only if the ones digit. Now notice we've talked about place value, so we know where the ones digit is, and it has to be one of these 5 even numbers. So a quick example, 38, we know to be divisible by 2 because the ones digit's 8, so this works, divisible by 2. What about 27? When we look at the ones, that's not an even number, that's an odd number, so this is not divisible by 2. So this is the first divisibility rule that we need. Okay, the next divisibility rule we're going to use is on page 86. And this is divisibility by 3. Now, divisibility by 3 says a whole number is divisible by 3 if and only if the sum of the digits, is a number divisible by 3. Okay. Now this is an interesting one. This is one that kind of gets people a little bit, so we're going to make sure to highlight. It's the sum of the digits. So the number, whatever number it is. Let's look at a number. Let's look at 27. Is this number divisible by 3? Well, like I said, in the past, people would look at it and go, yes, no, they might remember, they don't. We actually have a rule now that helps us find this every time. And what we do is we take the digits here of 27. So notice that the digits, I'm going to put an arrow here. The digits are 2 and 7, and we add them together. That makes 9. 9 is divisible by 3, so that means 27 has to be divisible by 3. Let's use a larger example. I'll just make one up here. What about 634? Okay, again, you ask students, hey, is this number divisible by 3? They maybe, no, yes. But we have a way of finding out for sure. So we'll take these digits, 6 plus 3 plus 4. 6 plus 3 we know to be 9. 9 plus 4 we know to be 13. 13 is not divisible by 3, so this number cannot be divisible by 3. Now what if I make this number 6,342 now? Is that number divisible by 3? Well, again, go straight to your new divisibility rule. 6 plus 3 plus 4 plus 2 now. We know the 6 plus 3 was 9, plus the 4 is 13, plus the 2 now is 15. Is 15 divisible by 3? Yes. So since 15 is divisible by 3, that means this whole number has to be divisible by 3. Now, just to check and show, let's look at this. 3 goes into 6 2. 0, drop the 3. 3 goes into 3 once. 0, drop the 4. 3 goes into 4 once. 1 left over, drop the 2. So 3 goes into 12 4. So we have our 12, and we get 0 remainder. So 3 does go into that number 2,114 times. So the rule helps us determine whether 3 would go into it or not. And then here's another little trick that helps you. Let's say you have a big number and you get to a number. Let's say you didn't know the 15. You can apply the rule to whatever you get. So notice I got this. I can also take 1 plus 5 and make 6, and that's divisible by 3. So no matter how big the number is, if you add up the digits, whatever you have left, you can add it up again if it's more than one digit and see if it's divisible by 3. This is a very powerful rule. It's going to help us out a lot. Okay, we don't necessarily need one for 4 because 4 is just 2 times 2, so if 2 goes into it, then that helps us break the number down. Keep this in mind. What we're trying to do is break numbers down. Okay, let's do a divisibility rule for 5. This is also on page 86. Okay, this is divisibility by 5. Now, divisibility by 5 is very similar to 2 because it's a whole number is divisible by 5 if and only if, and I'm going to put ditto mark here so you can see that that comes from the 2 or the 3. if and only if the ones digit is 0 or 5. Okay, so example, 32 is not divisible by 5 because the one digit's a 2, but 40 is because the one digit is 0. So these are our divisibility rules that are going to help us break numbers down. It's going to be very important moving forward.